So let's do a bit of a review on polynomials. And so we are on page 265, not 263, 265 in your workbooks. And this is just a bit of a review. So last year we started a bit on polynomials and recognizing some of the terminology associated. So we'll just be continuing with that this year. So just going through some of the terminology, that's the basis for this particular lesson. So lots of these you guys should already recognize. So of course, variable being a letter that represents one or more values. An algebraic expression, of course, that you guys are very familiar with, and some of our algebraic expressions are called polynomials. So if we wanted to be more specific, we have a monomial, and mono being a prefix for one. So a monomial it can be just a number on its own, or a variable on its own, or the product of a number and variable. So I kind of prefer that it's a product of numbers and variables, or a number on its own. I wouldn't really say a variable on its own, because we could say that it's a product of one and the variable. So the other thing that we recognize is the exponent on the variable must be a positive integer, and also in the numerator. So the exponent of any variable must be a positive integer. So they've given several examples, and the number that multiplies by the variable is our numerical coefficient as well. So a polynomial then can be a monomial, or a sum of monomials. So again, you could say that it's a difference of monomials, because of course there can be subtraction. I would just prefer to keep it as a sum, because then you're adding a negative value, and that helps to separate our numerical coefficients. So if I'm subtracting 2x, so say it looks like 3 minus 2x, we can say that that's the same as 3 plus negative 2x, and that just helps us to see that the coefficient is negative 2. So 5 over x plus 3 is not a polynomial. Why? Because we have a variable in the denominator. So a polynomial with one term is a monomial, as we said before. A polynomial with two terms is a binomial, prefix bi, and three terms is a trinomial, prefix tri, and a polynomial with four more terms, we just call it a polynomial. So if we take a look at the following, then class example number 1, state whether the expression represents a polynomial or not, and if the expression doesn't, then explain why, and if it does, then is it classified as a monomial, binomial, trinomial. So just hit pause for a moment and we'll go through these and fill these. So let's check our work. So for A, it absolutely is a binomial. We are totally fine with it having a coefficient of 1/4. So coefficients can be anything. We're really just focusing on the variables, and that helps to determine whether or not an algebraic expression is a polynomial. So for B, our issue is this exponent 1/2. 1/2 is not a positive whole number, so that is not a polynomial. For C, yes, root 7, totally fine as a coefficient, so that is a trinomial. So there's our 1, 2, 3 terms. For D, again, we have the issue with this exponent of 2/10, and which is not a positive whole number. For E, our variable cannot be in the denominator. Let's take a look at class example number 2. So you guys have seen tables like this before previously last year. So let's go through this. I'll go through the very first one with you, 4x plus 3yz. So the number of variables they're referring to is 3. So the variables being x, y, and z. number of terms, we've got 4x and positive 3yz. So we've got two terms, so then the name is therefore binomial. So again, hit pause, complete the rest of the table, and come back and check it. So have a look at that table where we've filled in the number of variables, the number of terms, and the name of the polynomial, the name, of course, being based on the number of terms. So let's take a look, classifying polynomials by degree. So it depends on whether or not we're talking about a monomial or a polynomial with more than one term. So a degree of a monomial is simply the sum of the exponents on its variables or variable. So 2x to the fifth would have a degree of 5. AB cubed c squared has a degree of 6 because remember there is an unwritten 1 on the A, so we've got 1 plus 3 plus 2 happening there. The degree of a polynomial is the same as the degree of the term with the highest degree. So it sounds funny, but the easiest way to go through this is to look at the degree of each term. So in the first term, my degree is 2 plus 2 or 4. The degree of the second term is just the 4 right here. And then we've got a 1 plus 4, which is 5. And when we have just the constant, a numerical term, the degree of that is 0. So the highest number that we just wrote was 5. So the degree of that polynomial is 5. So you won't add across multiple terms, so you can add within a term, but if we have multiple terms, just simply take the highest value for a term. So you still have to add in each particular term. If a polynomial has a term of degree 0, so there's no variable, then that is our constant. And so in the polynomial, 3x squared y squared minus 2x to the fourth plus xy to the fourth minus 2, the constant term is negative 2. So we always want to include the negative as well. Let's take a look at class example number 3. So lots and lots and lots of possibilities, of course. So go through each of these and we'll take up some possibilities. Hit pause. So there's obviously lots and lots of possible answers. You can take a moment and confirm with your neighbor to see if they agree with the algebraic expressions that you've chosen. So binomial degree 1 in one variable. So if I'm only looking degree 1, I could have 2x plus 3x. The problem with that is because they're like terms, somebody might argue with you that that should actually be 5x. So we'd be safe in saying that it's 2x plus 3. So I've got a degree of 1, and it is a binomial. I only have one variable. A trinomial in two variables with a constant term. So I need 3 terms, 2 different variables. I have to have a constant. I've decided my constant is -2. You could have made it a positive, of course. And I need 2 variables. So I've got 3x plus 4y. Again, we could repeat variables. I could have 3xy plus 4 x squared y, even changing up the degree because that hasn't actually been specified. For C, a monomial of degree 6, numerical coefficient of 9. So we've got some limitations because it has to lead with a 9 because that is our numerical coefficient. And it is a monomial, so I can't add or subtract anything, and it's degree 6. So that means that the sum of the exponents, so 3 plus 3 has to be 6, or you could have a single variable with exponent 6. So a few possibilities, but there's definitely more limitations there. For D, a binomial degree 8, each term containing 2 variables. So again, we've got 2 terms. It could be addition or subtraction because it doesn't specify what the coefficients are. If you wanted to have coefficients other than +1, as I have, you're welcome to do that. Each one has 2 variables. Again, it doesn't specify that they have to be the same. Degree 8 simply means that one term has to have 8. The other one, I could have x cubed y cubed here instead of x to the 4th y to the 4th because we're just taking the term with the highest degree. So again, I could have had, let's say, x to the fourth, y to the fourth, and simply plus xy. So that would work as well. Let's take a look. Then, if we have polynomials in a single variable, we typically will arrange them in ascending or descending order of degree, so order of the powers of the variable. The leading coefficient of a polynomial, single variable, is a coefficient of the term with the highest power of the variable. So perhaps that sounds a little confusing, so let's do a couple of examples. If we see the polynomial expression 2x minus 4x cubed minus 7 plus 6x squared over 5, couple of things. First off, we might actually take 6x squared over 5 and rewrite that so it's 6/5 x squared. So it's very obvious what that coefficient is. That the coefficient, again, is the number that you're multiplying by the variable. So if we write the polynomial in descending powers of x, so we're looking at the exponent on the x, so then that means we've got negative 4x cubed, because that is our highest number. We're descending, followed that by 6/5 x squared, and then x to the 1, so that's plus 2x, and then our constant is minus 7. If we're writing it in ascending powers of x, so we'll rearrange it. The sign has to stay with the number. So now we're looking at negative 7 plus 2x plus 6/5 x squared minus 4x cubed. So if we're looking at the leading coefficient is negative 4, because that is the coefficient, the number being multiplied by the variable based on the highest degree. And the constant term in this case is negative 7. So if we state the numerical coefficient of x squared, we're looking at what value is multiplied by the x squared, and that is 6/5. Okay. Most times you're going to see it written in descending order of degree, but you do occasionally see it in ascending order of degree as well. Okay, so back to algebra tiles. So algebra tiles give us a visual representation. These are going to be very helpful for us to understand how it is that we can multiply with polynomials, as well as how we can factor with polynomials. So typically speaking, you can look for a legend, but here, as well as in the textbooks, oftentimes they're using positive being shaded and unshaded being negative. The little unit squares are 1 unit, your strips are 1x, and your box is an x squared. Again, why is it that they've come up with that? These are based on the area themselves. So this is 1 unit by 1 unit. This is 1 unit by, I don't know what the length is, so it's 1 times x, which is x, whereas this measures x by x, which is why we have an area of x squared. Okay, so the polynomial expression, which describes each diagram. So again, this should be review for you guys. This is negative x squared plus 2x plus 1. In this case, we've got 2x squared, and then our x's, because we have a positive x, and this is a negative x, these essentially cancel each other out based on the zero principle. And again, we've got negative 2 here and positive 2, so they again cancel each other out, so I'm just left with the negative 1. So we've got 2x squared minus 1. If you wanted to, we could actually say 2x squared minus x plus x minus 3 plus 2, and then simplify that as well to 2x squared minus 1. Okay. So taking a look then, using algebra tiles to determine the results of the addition. So again, let's just hit pause. You can draw a quick diagram and then come up with the addition. So if we draw those out, remembering that addition is just combining, so no different than when you were in kindergarten or grade 1, they said you had 3 apples and you add 2 more apples. It's just putting them all together. What is your total? So subtraction, the easiest thing to do with subtraction is to add the opposite inverse or the opposite polynomial. So that is essentially just like what we typically would do, which is to distribute a -1 in. So that gives us then 4x plus 3, and then that is plus -2x, and then plus 5. So if we were to then combine these two based on subtraction, again, they're asking you to use algebra tiles. What we don't want to do with algebra tiles is draw out the tiles and then just put a minus in between. Rather, let's change that to the addition of the opposite and then draw out the algebra tiles as an addition question instead. So convert it to addition first. Okay, again, let's hit pause and we'll go through that. So looking at our result, we should have -3x squared plus 4x minus 1. Okay, so if we were adding and subtracting without the algebra tiles, of course, we're paying attention to like terms. So like terms we talked about previously, so they have the exact same variables with the exact same combination of exponents. So we're not paying any attention to what the coefficients are, only to the exponents. So unlike terms may have different variables or the same variable but different exponents. So let's take a look at class example number 8 then. And so they've got some addition and some subtraction. When we look at the subtraction for part B, again, my strong recommendation would be to take the subtraction and make it into the addition by distributing the negative. The reason being that if you were to actually think about it as totally subtraction, our brain usually, when it sees things lined up, it instantly just wants to add. And so by the time we might remember 4x squared minus 2x squared, by the time we keep working down the line, we've forgotten that we're subtracting, and people usually end up just going ahead and adding. So that's why I would always suggest you go through and simply change it to addition and change your signs. So again, hit pause and complete these examples, please. So taking a look at these, you can see for A, sometimes people find it easier to either circle or to underline or use squiggles, colors, just to help them to identify what their like terms are. Again, another way is simply to go through it alphabetically. While we talked about putting them in order of degree, oftentimes we also take a look at the alphabetical order if that's relevant as well. So I looked at the A's, 3A minus 3A is obviously 0 A's, so there's no need to write 0 A's down. And then we've got -4B and -4C. For B, if you are writing it out vertically, it makes a lot of sense to, of course, have all of your like terms all lined up then. Okay, so let's take a look then at the next section. Okay, last class example is just simply, again, simplify, which means to collect like terms. So there's just more terms and a variety of exponents happening. So identify those like terms, combine those together. So just hit pause and work through these. So taking a look at these examples, so again, for the first one, I've rewritten them, combined my like terms and rewritten it in descending order of degree. For B, I've chosen A alphabetically and looked at then A cubed, A squared, and A, but again, combination of the like terms, and of course recognize that AB squared is going to be the same as B squared A. Ideally, you're looking at it in alphabetical order, but occasionally we might mix it up on you, and so just be mindful of that and just rewrite it as AB squared so it's easier for you to identify your like terms. Okay, so that's it. Just a quick review. Please ask questions if you have questions, and take a look at the assigned work.